All right. Hi, guys. It's Vaughn here. Just going to take a little bit of time in your snow day to do some virtual learning. I am not going to make this long. This is for my pre-algebra class. We're going to be working on our chapter 3 study. I know I still got my sleep bonnet on. I'll probably just leave it on all day. Look, I even have, can you see them? I have my kitty cat socks on because it's cold. So let's go ahead and get started. Share screen. Where is it? There we go. Okay. Let me hide myself. All right. So, darn, I forgot my pen. Okay, I'm just going to use this. We're only going to do the first page, which is not too super hard. So, in this first part, we're looking at our sets of numbers. We have, okay, we have some terms. So, another term for natural numbers. Now, all of this is in the beginning of your textbook section on sets of numbers, but another term for natural numbers is actually counting numbers. So you have that. What number must be added to the set of natural numbers to make it a set of whole numbers? So if you remember the Venn diagram that we did, you have that very small circle in the middle, which is your natural numbers. Then you have the next set, which is whole numbers. The only number that's different is the 0, the Z. Okay. Now, true or false? All whole numbers are integers. This is true, right? Because the set of whole numbers exists within the set of integers. The only thing integers do is they add your negative numbers. So all whole numbers are still integers. So this is true. Okay, all irrational numbers are real numbers. Now remember, real numbers is that whole big box that all numbers are real numbers. Therefore, irrational numbers are still real numbers. So this is true. And then here's another true false. So when you think about this, the square root of all even numbers are rational. Oh, that should be is rational. Don't tell your English teacher on me. Okay, so let's look. Okay, so square root of 2. 2 is an even number, but is there a number that when divided by it, or excuse me, multiplied by itself equals 2? That answer is no, because 1 times 1 is 1. 2 times 2 is 4. Had a moment there. So already we know that this is going to be false. So think about that. If you get a question that says like the square root of all odd numbers are irrational, or the square root of all even numbers are integers, just think about all of the numbers. Very quickly, you'll see that a lot of those are false. Okay, we're going to skip 6 and 7 real quick. We'll do those in class tomorrow. Let's work on simplifying some expressions and then solving some equations and inequalities. So remember, for numbers 8 and 9, when we simplify expressions, you need to know to look for your like terms, and then you combine them, right? This should be old hat for us. But going back to when I originally taught this to you guys, I'm going to use my baby steps here. So you see that my first term is 8p. So I have the variable p with no shown exponent. So it's just 1. All right, so I need to look for another one. The next one's q, that doesn't match. But then I have a 2p. Now remember, please remember, when we talked about this, you need to keep the sign in front of the term with the term when you're combining like terms. So keep that negative there, because a subtraction quickly becomes a negative when you start combining terms or distributing or factoring, that kind of thing. Okay, I don't see any more p terms, so let's look at the q terms. So we have negative 4q, we have negative 3q, and looks like that's it. And then we have this constant term here, but just one of them. Okay, so let's combine like terms. 8p minus 2p minus 4q minus 3q plus 4. All right, so then you should know you can factor out the p and you end up with 8 minus 2p. Now, this is where your negative sign your subtraction sign becomes a negative. So add a plus sign here, and then you have negative 4 minus 3q. That lets you see a little more easily that you are adding like terms, negative 4 and negative 3. It's going to become negative 7. Okay, and then we have our 4 here. All right, so 8 minus 2, that's the easy one. We have 6p, but then we add negative 4 minus 3, which like terms, so you add them together, keep the sign, that becomes negative 7q, and then we have our plus 4. And now we are as simplified as we can get. So 6p minus 7q plus 4. Okay, so let's look at the next one. In this case, it looks like we have all y terms or constant terms. So we have negative 6y, positive 7y, and we have a negative 10y. And then we have two constants. We have 9 and negative 4. So negative 6y plus 7y, just change that to minus 10y, plus, just say 9 minus 4, and throw that together. All right, so we're using baby steps here. Negative 6, we factor out the variable so that we can add the coefficients together, or subtract, for that matter. Okay, plus, and then 9 take away 4 is 5. All right, so negative 6 plus 7 gives us 1, but then 1 minus 10 is negative 9. So this becomes negative 9y plus 5, and we're done. Excuse me, sorry for the sniffles. Okay, so let's look at solving equations and inequalities. Obviously, well, hopefully it's obvious, right? If the sign between the two sides is an equal sign, then you know you're solving for an equation. If it is a greater than, less than, or they're equal or equals to, then you know you're solving an inequality. Okay, so for the first one, number 10, we have 5w plus 9 minus 2w. So it looks like we need to combine like terms here. I'm going to go ahead and eliminate some of those baby steps and just show you what we do with the two like terms there, 5w and negative 2w. So it becomes 5 minus 2w. I went ahead and factored out the variable, and so this becomes 3w plus 9 equals negative 12. Hopefully y'all can pause this part of the video, go ahead and do these, and then just check your work, because we've done a lot of practice with these. Y'all should be pretty comfortable with these. The only thing I would say with these is to check your math, right? Because negative 12 minus 9 is adding like terms. So you add 12 and 9 together, you're going to keep that negative sign. 12 plus 9 is 21. So we have negative 21. You divide both sides by 3, and you find that w equals negative 7. All right, let's look at number 11. Now remember, when you have an expression in the numerator, treat that with understood parentheses. And then when you do reverse order of operation, you know that you're going to do your parentheses after you do any multiplication or division. So in this case, we need to get rid of that negative 2 denominator first. So we multiply both sides by negative 2. And we end up with 2x minus 16 equals 18 times negative 2, which is negative 36. All right, so let's then add 16 to both sides, inverse operation. So 2x equals, now in this case, we are adding unlike signs. So your answer is going to be negative because 36 is the larger value. And then you subtract 16 from it and you end up with 20. Right, so then you divide both sides by 2 and you get x equals a negative 10. All right, number 12, we're looking at inequalities here. So be careful when you know you're working with inequalities. If you divide or multiply by a negative number, you must reverse your inequality sign. So let's go ahead and combine like terms here first. We have 12y minus 2y. So let's go ahead and simplify that down to 10y is greater than or equal to negative 50. So in this case, to solve for y, we need to divide by 10. So in this case, are we dividing or multiplying by a negative number? Well, we are not, because the 10 is positive. So your inequality sign is going to stay the same, and you end up with y equals negative 5. Excuse me, y is greater than or equal to negative 5. Now, like I said before, if you are not sure if you should have switched your inequality sign, plug that value back into your original equation and see if it makes sense. All right, let's see here. Or plug a value that matches like the y greater than or less than. All right, so number 13, we definitely have to do some simplifying here. So we need to distribute the 6 into 3d plus 2. So remember, we've done so much factoring, we sort of forget the distribution part. You must distribute 6 times 3d and 6 times 2. So we would write that out this way. If you need the reminder, you can, of course, always do this in your head. These are pretty straightforward. All right, and so 6 times 3 is 18. So 18d, and then 6 times 2 is 12, minus 8 is 40. So let's add our 12, simplify that 12 minus 8. So 18d plus 4, 4 equals 40. All right, so then it's just, we get rid of that 4 first. 18d equals 36. Divide both sides by 18, and you discover that d equals 2. Okay, so now I have a very intimidating one. But again, take it step by step. In this case, because you have an unsimplified expression in your numerator, I would simplify that first, then start solving by doing your inverse operations back and forth across the equal sign. Okay, so let's go ahead and distribute this 5 in the numerator. So this becomes 5x plus 15 minus 4x. So then we have 2 like terms here. So 5 minus 4 is 1. So this just becomes x plus 15. All right, so x plus 15 divided by 4 equals negative 21. So again, treat this like it is in parentheses. So it's one expression because it's in the numerator. So you would do that last. You get rid of this 4 in the denominator first. Okay, so you multiply both sides by 4, and we end up with x plus 15 equals 4 times 21, which is 84, negative. All right, so now let's subtract 15 from both sides. Now remember, when you are subtracting a number from a negative number, that means you're adding like terms. So you add these together, but you keep that negative sign. So x is going to equal negative 4 plus 5 is 9, 8 plus 1 is 9. So it equals negative 99. All right, number 15. So we have an inequality here. So we have 7x plus 42 minus 11x is less than or equal to 30. So let's combine our like terms. 7 minus 11 is going to be negative 4x plus 42 is less than 30. So we subtract 42 from both sides. Remember, you do not reverse your inequality sign when you're adding or subtracting, but you always check when you're multiplying or dividing. All right, so this goes down to negative 4x is less than 30 minus 42. We are adding unlike signs, so 42 take away 30 is 12, and the 42 has the greater absolute value, so that is your negative. Okay, now we are dividing both sides by negative 4. Now in this case, do we need to reverse our inequality sign? Yes, we do. We are dividing by a negative number. So when you reverse it, x must be greater than negative 12 divided by negative 4 is a positive 3. So x must be greater than 3. So find about, just throw in 4 into your original equation. If this is true, if x must be greater than -3, then plug in the value 4 for all of the x's in the original equation. If the original inequality, if the inequality is true with a value such as 4, then you know you have done it correctly. Okay. Last two. Number 16, pretty straightforward. The big thing to remember with this one is when you have a negative in front of a fraction, where does the negative go? Is it supposed to be part of the numerator or supposed to be part of the denominator? Well, if you remember, it can be either. The key is it can only be one. Because remember, if you have a positive divided by a negative number, your answer is negative. If you have a negative divided by a positive, then your answer is negative. But you can't have it in both because that would give you a positive answer. So to make this simple, so it's only sort of a one-step deal, put the negative in the denominator with your constant value so you can carry it with the number when you go ahead and do your inverse operation. So in this case, we're going to multiply both sides by -5. And that way we just end up with x equals 30. That's an easy one. Let me show you something else. If you don't do that, let me just show you because we've seen that. So say you keep the negative with the x in the numerator, -6. So then you multiply both sides by 5, and you end up with -x equals -30. Well, -x is not x. That's essentially x times -1. So the inverse operation of multiplication is division. You would have to divide both sides by -1 and then see that x, a negative over negative, is positive. So x equals 30. So it just adds an extra step there, no matter where you put that negative sign. No, I need 2 more. But just remember, you cannot leave it -x because that is not x's value. Okay, last one, number 17. We have -8 times 5b plus 94 plus 4b equals -50. So another equation. We do need to go ahead and combine the -8 and 5. So let's simplify. -8 times 5 is -40. B plus 94 plus 4b equals -50. All right, we've got two like terms here. So -40 plus 4 is a -36 because you're adding unlike signs, so you find the difference. -50, let's subtract 94 from both sides. Why did I make this one? I'm going to do a careless error here on video. 36b equals, okay, so like terms, right? They're both negative. So we just add them together. 4 and then 5 and 9 is 144. I thought you were going to make the waterfall. Okay. Okay, so -30. So we divide by -36. So our answer is going to be positive, right? Because we have a negative divided by a negative. And so I think this is 4, right? Because 30 times 4 is 120. And 6 times 4 is 24. And when you add those together, you get 144. So yeah, so B equals 4. All right. And that's it. So if you guys have any questions, please jot them on this study guide, and then we can talk about it when we get back in class together. Otherwise, we're done with pre-algebra. So thank you so much. I appreciate all of your hard work. Now go enjoy the snow if it's not too ridiculously cold, because that wind, I'm staying inside. I'm a polar bear and I'm still not handling this. All right. Bye, guys.